Okay, so we're going to build on yet another one of those topics that we briefly touched on in the fall. This one is what's called numerical integration. Okay, and numerical integration just means tricks for finding the area between a curve and the x-axis that don't involve integrals. They involve the left-hand rule. Well, they include the left-hand rule, which is, get my pointer out of here, if I remember which one it is. I guess I get to point that way. Nope, that doesn't work too well. All right. The left-hand rule says, there we go. The left-hand rule means that when you're making your rectangles, you choose y values on the left side of your starting area to determine the height of each rectangle. For the right-hand rule, you choose y values on the right side of each rectangle when you are determining the heights of your rectangles. For the midpoint rule, you pick the point in the exact middle of each rectangle to determine the height you're going to use to find the areas of each rectangle. And for the trapezoid rule, well, for the trapezoid rule, you draw a bunch of trapezoids. And it helps here to remember that the area of a single trapezoid is 1/2 base 1 plus base 2 times the height of that trapezoid. Now, for each of these trapezoids, the bases are a little different than you might remember from geometry. The definition of the bases of a trapezoid is actually that the bases are always the two parallel sides of the trapezoid, and the height is always the distance between those parallel sides. So when you're using the trapezoid rule, the height of your trapezoid is always going to be some delta x value, and the bases of your trapezoid are going to be the y values on the curve that we're trying to approximate the area underneath. Okay, let's jump to an example of how this works, and hopefully we'll have time in this video to do a free response problem, because that's a homework I'm going to have you guys try. All right, example 1, use the trapezoid rule and the midpoint rule with n equals 5 to approximate the integral from 1 to 2 of 1 over x dx. Okay. Don't necessarily need to do a graph, but it helps. I'm sure you all remember that the graph of y equals 1 over x in quadrant 1 is the positive half of a hyperbola that's been rotated 45 degrees. Believe it or not, we did do that last year. Okay. We're starting at 1. We're ending at 2. And we're splitting this into 5 shapes. First, our 5 shapes are going to be trapezoids. Trapezoid rule will do a pretty good job here. Because this curve is smiling and decreasing, the trapezoid rule, 1, 2, 3, 4. Yeah, I did not space this very well. The trapezoid rule here will be an underestimate. Now, we need to know 2 things. We need to know these y values, and we need to know the x values at all the vertices on our trapezoids. So, well, for the x values, if you take all the points between 1 and 2, and you split them into 5 subintervals, you're going to go 1/5 of a jump for your delta x between each one. So this x coordinate right here, that would be 1/5 more than 1, be 1.2, but I like decimals better. So I'm going to call this 1/5 more than 1, 6/5. Like I just said, I like decimals better, and I actually like fractions better is what I meant. If I keep going up by 1/5, I get 6/5, 7/5, 8/5, 9/5, and then 2 would be 10/5. If you have a 4-function calculator accommodation, decimals might legitimately be easier. As for these heights, well, the graph is y equals 1 over x. So to find the y values, I would take the reciprocal of the x values. So this is going to be the point 1, 1. Here, when x is 6/5, y would be 5/6. When x is 7/5, y would be 5/7. When x is 8/5, y would be 5/8. When x is 9/5, which I wrote incorrectly there, y would be 5/9. And when x is 2, y would be 1/2. So now we need to find the area of all these trapezoids, which means our only calculation would be area is, okay, my first trapezoid, I'll shade in yellow there, 1/2 base 1 plus base 2, in parentheses would be just the y values go here. Go in the parentheses, so that would be 1 plus 5/6. The height of my trapezoid is going to be lost my laser pointer for a minute there, is going to be this delta x, that width. And each of these delta x's are the same. They're all 1/5 long. So that would be times 1/5. My second trapezoid, one in green, indicate that's the one in yellow, is going to be 1/2 5/6 plus the other side has a height of 5/7. Close that parentheses there, times the same delta x of 1/5. And we're just going to keep going. We are going to do 3 more trapezoids. 5/7 will again be the side length, and then 5/8 will be the next one, times the delta x of 1/5. 2 more to write up, plus 1/2 5/8 is going to show up again because it's the side of the next trapezoid, times the delta x of 1/5. Running out of colors that I like. That would be that trapezoid. And again, I realize my drawing is not even remotely to scale. 5/9 plus 1/2 times 1/5, and that is my last trapezoid over here. Hopefully this would be a calculator problem. I'm not going to calculate all this out right now. I just wanted to show you the setup for the trapezoid rule. But the problem also said to do the midpoint rule. So we have to do this whole problem again. And let's see what that would involve. Okay. It's going to be the same subintervals. I don't need to change my bottom, where I put the dividers, but it's a little bit different. See, somewhere between, I'm going to use decimals for this one. That might actually be easier. We'll find out. So for decimals, this would be 1.2, 1.3, sorry, 1.2, 1.4, 1.6, 1.8. Now, for the midpoint rule, what we do is we create a rectangle whose height passes through the y value that lines up with the midpoint of each interval. So what's halfway between 1 and 1.2? 1.1. So the midpoint of my first rectangle is going to be the point 1.1, and the reciprocal of 1.1, yeah, I'm going back to fractions. Sorry, guys. 1.1 is 11 tenths. Its reciprocal is 10 over 11. I create a new rectangle here that passes through the next midpoint. Midpoint of 1.2 and 1.4 is 1.3. That's 13 over 10. Its reciprocal is 10 thirteenths. I keep going, finding these midpoints and using them as heights of rectangles, which in a curve like this get kind of more annoying to draw. I find the corresponding y values and I make my rectangles. So I've got 5 rectangles to find, and my area calculation is going to be, well, let's see. Area of each rectangle is base times height, right? Well, all the bases are 0.2 or 1/5. So my first rectangle has a base of 1/5 and a height of 10 over 11. My second rectangle has a base of 1/5 and a height of 10 over 13. My third rectangle has a base of 1/5 and a height of 10 over 15, which is the same as 2/3. My next rectangle still has a base of 1/5, has a height of 10 over 17. My last rectangle still has that base of 1/5 and a height of 10 over 19. If you are having trouble keeping track of which of these little formulas corresponded to each rectangle, hopefully this will help. And again, this is just to give you the idea, so I'm not going to work out the calculation. I do want to make a point about the nature of this question, though. The question was not find the actual area, definitely not find the exact area, because, as you guys should know, the integral of 1 over x dx is the natural log of the absolute value of x plus c, which means the area between 1 over x dx and the x-axis is the natural log of x, and according to the fundamental theorem of calculus, we plug in the endpoints of our integral and subtract. So it's the natural log of 2 minus the natural log of 1. You guys hopefully all remember the natural log of 1 is 0. So the actual area we're looking for is the natural log of 2. Natural log of 2 is an irrational number. It literally cannot be expressed as a fraction with an integer on the top and an integer on the bottom. So what that means is these approximations we did, which would all eventually become one fraction with an integer on the top and an integer on the bottom, cannot be the exact area. Reason I'm stressing this is sometimes the AP test will ask you to find an approximation using a trapezoid rule, a midpoint rule, a left-hand rule, a right-hand rule. One of the answers might be the exact answer you would get for the integral, one of the choices, A, B, C, or D, or E. If that happens, if you see this problem and you just go, oh, I'll just anti-derive, plug in 2 and 1, and the natural log of 2 is the answer. If you write that on a free response, or if you circle that on the AP on a multiple choice question, you will get it wrong because the directions did not say to find the exact area. It said to find the approximate area using one of the numerical integration rules you've learned. Okay, so with that in mind, I'm going to pause the video and then we'll come back and we'll try this free response question.